Section 7.2, the Law of Cosines. Solving an oblique triangle means finding the lengths of its sides and the measurements of its angles. In the previous section, we studied the law of sines. We used it to solve angle-side angle and side-angle-angle. Both of those were the determined case, and we also looked at side-side angle, which was the ambiguous case. In this section, we need to learn the law of cosines in order to solve side-angle-side and side-side-side. Why do we need the law of cosines? Well, one example is side-angle-side, when you know two sides and the included angle, which means the angle between those two sides. In order to use the law of sines, we need an angle and its opposite side to be known. We know angle A is 120 degrees, but we don't know side A. We know side B is 7, but we don't know angle B. And we know side C is 8, but we don't know angle C. So we cannot use the law of sines. In a triangle that we know the side, we have a similar problem. We know all the sides, but none of the corresponding angles, so we cannot use the law of sines. Using uppercase letters to represent the measures of the angles and lowercase letters to represent the lengths of the sides, the law of cosine states that the square of the side of a triangle equals the sum of the squares of the other two sides minus twice their product times the cosine of their included angle. This works from the perspective of any of the sides, so we can also have b squared equals a squared plus c squared minus 2ac times the cosine of angle b, or c squared equals a squared plus b squared minus 2ab times the cosine of c. Here's a strategy we can use to solve a side-angle-side triangle. We'll begin by using the law of cosines to find the side opposite the given angle. We'll be doing this example shortly, but for now let's just discuss the strategy. The law of cosines will give us the side that is across from angle A. Side A, it'll turn out, will be 13, and we'll look at all the math in a moment. But from a strategy point of view, once we find it, then we'll know an angle and its opposite side, so we can move on to use the law of sines. When we use the law of sines, we'll be sure to find the side opposite the shorter of the two given sides, because by using the shorter side, we won't have to concern ourselves with the supplement of that angle. So B is the shorter side, we'll use the law of sines to find angle B. We'll see in a minute how that turns out to be 28 degrees. And then we can use the fact that we know these two angles to find the third angle. Since the three angles of any triangle add to 180, we can subtract the two we know from 180, and that'll give us 32 degrees for angle C. That's step 3, which is to find the third angle. Let's look at the example. In example 1, we have this side-angle-side triangle where we know angle A, side B, and side C. And notice that we do not have a side angle combination, so we cannot use the law of sines. So we'll begin by using the law of cosines to find the side that's opposite the 120 degree angle. We write the version of the law of cosines that includes angle A. We fill in the values, we start to simplify, and we get a squared equals 169. Take the square root of both sides, so a equals 13. For step 2, we can now use the law of sines because we have an angle and its opposite side known. When we do this, we're going to find the angle opposite the shorter side, and that's angle B. We know side A and angle A, and we know side B, so we can solve this using the law of sines. Cross multiply, divide both sides by 13, be sure your calculator is in degree mode, and find the sine of B. Since this value is less than 1, we know this is a valid angle, so we can find the inverse sine of 0.4663, which leads to B equaling 28 degrees. So we can label that on our triangle. Note that we found the angle that was across from the shorter side, because now that 28 degrees, we do not have to consider its supplement, because its supplement would be too big to be in a triangle that also contains 120 degrees. And now for step 3, we find the third angle. To do that, we recall that all the angles add up to 180 degrees. So C equals 180 minus the two known angles, which gives us 32 degrees. We've solved this triangle because we found all the unknown sides and angles. Now let's look at a strategy for solving a side-side-side triangle. That means we know all three sides, And the first step will be to use the law of cosines to find the angle that is across from the longest side. By finding the angle across from the longest side, we ensure we're finding the largest angle, which means the remaining two angles will always be acute angles. The longest side is 10, so we'll find angle B, and we'll look at the math in a minute, but it turns out that will be 98 degrees. Now that we have a side and its opposite angle, we'll be able to use the law of cosines to find either of the two remaining acute angles. That will give us two angles. So for step 3, we'll find the third angle by subtracting those two angles from 180 degrees. In example 2, we know all the sides, but none of the angles of our triangle, so we cannot use the law of sines. So step 1 will be to use the law of cosines to find the angle that's across from the longest side. Since the longest side is b, we'll use the version of the law of cosines that has b squared on one side and cosine of angle b on the other side. We can bring that negative term to the left side and make it positive, and we can bring the b squared term to the right and make it negative. Then we divide by the coefficient of cosine b, namely the 2ac. When we divide that on both sides, we get the cosine b equals an expression that we can substitute in for. The numerator works out to -11 and the denominator works out to 80. And now that we've solved for the trig function of our angle, we can find our angle. We take the inverse cosine of that expression. Be sure your calculator is in degree mode. We can label our triangle, and we're on to step 2. Now we'll use the law of sines, because we know angle B and side B, to find either of the two remaining acute angles. We can start by looking for angle A. We substitute in the values we know, cross multiply, divide both sides by 10, and we can approximate that sine of A equals 0.7922. Now that we've solved for the sine of A, we can find angle A. We take the inverse sine of that value, and A works out to be 52 degrees. So we can label our triangle and move on to step 3. Step 3 is to find the last angle. Since they all add up to 180, angle C will equal 180 minus the two angles that we already found, which works out to 30 degrees. So we have solved this triangle. In example 3, we'll do an application problem. A bat flying at point C spots a moth 7 feet away at point A at an angle of depression of 15 degrees. The bat also spots a mosquito 12 feet away at point B at an angle of depression of 34 degrees. How many feet apart, C, are the moth and the mosquito? As we begin this problem, we know only two sides and none of the angles. But since we know that this straight angle is 180 degrees, we can subtract the two angles of depression to find angle C of our triangle. 180 minus the 15 and the 34 degrees leaves 131 degrees for our triangle. So this is a side angle side situation because we know two sides and the included angle, so we'll need to use the law of cosines. We'll use the version that will allow us to find side C. We substitute in the values, and we compute C squared to be 303.2179. So C is the square root of that value, which means C is approximately 17.4 feet. So the moth and the mosquito are about 17.4 feet apart from each other.